Okay, a few more problems using both the 45-45-90 triangle theorem and the 30-60-90 triangle theorem. First diagram, we have one triangle of each. We have on the left a 45-45-90 triangle, and on the right a 30-60-90 triangle. So what I'm going to do is copy the diagram and paste it over to the side so I can go back to the original diagram and get rid of part of this diagram. And I work on part of it at a time. So I'm going to focus in first of all on the 45-45-90 triangle on the left. So getting rid of the triangle on the right, we have the hypotenuse is equal to 5 times square root of 2. So the theorem states that a leg, such as A, times the square root of 2 gives you the hypotenuse. So the hypotenuse divided by the square root of 2 should give you the length of a leg. So in this case, the square root of 2's cancel and we get A is equal to 5 and B is also equal to 5 because the two legs are equal. Now transferring that value back to the diagram, specifically the value for A equaling 5, I'm going to copy the diagram again and this time paste it down below. And now I'm going to get rid of the left-hand side of the diagram. So now we have a 30-60-90 triangle where the shorter leg, because it's opposite the 30-degree angle, is given as equaling 5. The value for C, the hypotenuse, is equal to that number times 2. And so C is equal to 10. And D is equal to that number, 5, times the square root of 3. Okay, so we've taken the original diagram, broken it up into two separate problems, and solved for A, B, C, and D. Next problem. If the diagonal of a square is equal to 10, well, we don't have the diagonal being drawn, so we'll draw either of the two diagonals. Doesn't matter which one we draw because they're both equal to each other. If that is equal to 10, then what is the perimeter of the square? So let's put a 10 there. Because it's a square, this is a right angle. Because it is a square, the diagonals are bisecting the angles, so therefore we have two different 45-45-90 triangles to look at, both of which are congruent to each other. And for either of the two right triangles, I'm looking at this triangle that I'm highlighting. That triangle, the theorem states that a leg times the square root of 2 gives you the hypotenuse. So to reverse the theorem, 10 divided by the square root of 2 should give me the length of a side of that square, or a leg of the 45-45-90 triangle. To rationalize that, we multiply by the square root of 2 over the square root of 2, rationalizing the denominator, that is, and we get 10 times the square root of 2 over 2. 2 goes into 2 once, 2 goes into 10 5 times, so we find one side is equal to 5 times square root of 2. So all sides are equal to 5 times square root of 2. So therefore, we just copy and paste it every place. And we have the perimeter, therefore, is all of those values added together. Or in other words, it's one side, 5 times square root of 2 times 4, which gives us 20 times square root of 2 is equal to the perimeter. And one more problem. If the length of the altitude of an equilateral triangle is equal to 15, then what is the length of one side of the triangle? So I've already drawn in the altitude for the triangle. If that is equal to 15, then we want to solve for x, one of the sides of the equilateral triangle. By drawing an altitude for an equilateral triangle, we're forming two side-by-side 30-60-90 triangles, this angle being 60 and the angle at top being bisected to give you a couple of 30-degree angles. So we have a 30-60-90 triangle to look at. The shorter leg, the segment at the bottom in the green triangle, is equal to the longer leg, which is the 15, divided by the square of 3, because to find the longer leg, you multiply the shorter leg times the square of 3. So rationalizing that denominator by multiplying by the square of 3 over the square of 3, you get 15 times square of 3 over 3, which gives you 5 times square of 3 for the shorter leg. The hypotenuse, which is also the value for x, a side of the original triangle, is that number, 5 times square of 3, doubled. So 2 times 5 is 10. We get 10 times square of 3 is the value for x, which also answers the question.